I hope you had a nice summer. I will bring up my presentation. Um, right. So, so I will speak about the services that Cincino offers for, no, Vitas offers for Cincino, especially the credibility that we add to the collaboration, the accuracy, and the precision of the testing, and what puts us ahead of the competition and how we can stay ahead of the competition. So, as you might know, Vitas is a contract research organization. It's abbreviated CRO. We develop, we validate, and we apply analytical methods for different purposes for our sponsors. I don't know if you've been visiting our website, but I think you should do. You will learn a lot about our history. You will learn that we are actually have been in operation for 32 years, established in 1994. You will learn that we have a GMP certification, meaning that we can do human clinical studies and we can release drug products to the European and US market. You will see what kind of customers we work for. You will see a list of publications where the employees of the company are co-authors. You will see an even longer list of publications where we are not co-authors, but where we have done the analytical work. And since we've been in operation for more than 30 years and we have hundreds of projects every year, this list is really, really long. And you will also see the kind of experience and diversity we have based on the topics and the titles of the publications. We also have a list of methods, applications that we have developed in-house. Currently about 660, 70 methods. Some of them we use every day, some once a month, and some once every 10th year, depending on the need of our sponsors. We also have a section with testimonials, some nice words we have collected over the years from key collaborators, professors from Cambridge and like King's College, and also Doug, the CEO of Cincino. And this kind of summarizes to this slide. So in addition to what I already mentioned, you can see from the text here that we actually just recently reached a milestone, having performed more than 3 million DBS samples in total. We receive 60,000 samples per month now, increasing. We add extra methods, maybe 10, 15 methods every year for our customers. We have been partner in a number of EU-funded projects, which is very competitive. And we, as I mentioned, collaborate with Ivy League universities and top researchers. And resulting from these collaborations are also very, very high quality scientific publications published in high impact journals like the BMJ, Medicine, Nature Science, and the Lancet family of journals. And last but not least, I think it's worth mentioning that, yeah, we are financially stable. I mean, we've been around for 30 years and we're going to be around for another 30 years. And I think this is a nice thing to know for those that use us as subcontractors. So going into the things we do for Cincino, there are 4 tests. The balance test, been there for, I don't know, 15 years. The gut health test, the newest one, the vitamin D test, and the HbA1c test. So I think it's important for you to know how this service is divided into at least 3 units. It's the DBS kit, which is a medical device, class A. It's used to collect the blood at home and contain it in a safe way, and then also to transport it to the lab. And this is the sole purpose of this medical device. Although it says balance test, vitamin D test on the box, this is not a part of the intended use of this device. So the second one is Vitas, the independent lab performing the analysis. on the samples sent by Cincino customers. So the kind of the organizer and the owner and the customer-facing entity in this kind of triangle is Cincino. And it is organized like this. Cincino on the top, having subcontractors like RDA Spot and Vitas. RDA Spot and Vitas is not connected in any way. We have agreements with Cincino, both of us. And then again, Cincino has an agreement with the customer. So Cincino agrees for the customer what they can do with the blood sample, and that's the only thing they can do. And I think it's important that we keep this separation. We don't regard it as an integrated service, but separated units, companies that have contracts that bind them together. So common for all of these tests is the collection of blood using the medical device produced by RDA in Lithuania. And this blood is very similar to the blood that are collected by the doctors and at the hospital. For all practical means, there is no difference. And you can see and you know that it's red when it's coming out of the arm, but if you wait a few hours, this will happen. The red blood cells, being heavy, they will sink to the bottom, and on the top, the yellow plasma will appear. So this yellow plasma fraction is what your doctor and the hospital usually would use for analysis. I would say 99% of all biomarkers are analyzed from the top fraction, the yellow plasma. But the red blood cells, they are also quite interesting. They look like this, like flat donuts, and they are produced in the core of your bones, in the bone marrow. And every second, 2 million cells are born. I think it's quite fascinating. Think about it, 2 million. 4 million, 6 million cells. And of course, at the same time, the same number has to die or it will pile up in your body. And when they are born, they live for about 120 days on average. And the cell and membrane of these cells, which is almost identical to the membrane of all cell types in the body, is constructed from phospholipids. And these phospholipids, they have fatty acids connected to them. And these fatty acids, they can be different types: saturated, unsaturated, polyunsaturated, omega-6, omega-3, DHA, EPA, arachidonic acid, and so on. And these are the fatty acids that we analyze when we do the balance test. So a very well-known function of these red blood cells is to transport oxygen from your lungs when you breathe. And this oxygen is connected to hemoglobin, the red color of the blood inside the cells, and it is then transported by the blood and the pumping heart to the different organs and cells in the body, like the brain. And on the way back, when oxygen is released, it will bring carbon dioxide out of the body. But there are other biomarkers or other nutrients, building blocks, also carried by the red blood cells. For instance, 99% of iron is transported inside the red blood cells. The same with potassium, hemoglobin, HbA1c, and a number of other biomarkers. While in the yellow plasma fraction, you will find almost 100% the different vitamins like vitamin D, vitamin A, and different proteins like albumin, CRP, the gut test metabolites, tryptophan, and so on, and many, many other types of lipoproteins like HDL, LDL cholesterol, and so on. There are also some biomarkers that exist both in the yellow fraction and in the red blood cells like glucose and sodium. So when the heart pumps blood delivering nutrients, it's not pumping pure plasma, not pumping red blood cells. It's both. It's a mix, right? So because of this, what your cells and organs are exposed to is the things carried in both fractions in whole blood. So for me, it makes sense to use whole blood and not plasma for biomarker analysis. So starting with the balance test. So this test measures a set of fatty acids 11 in total. And the most important ones are the one in red brackets here. It's the omega-6 arachidonic acid and the two omega-3s, EPA and DHA. And for this measurement, we use a technique called chromatography. It's gas chromatography, so it's gas pushing molecules through a column. And the result from this analysis is called a chromatogram. And you can see it here. You can see these blue peaks. Each of them represent one molecule, and in this case, it's fatty acid. And the first one, the high one here, would be arachidonic acid. Then you have EPA and DHA. So when we are to calculate the omega-6-3 ratio or the AA-EPA ratio, we actually look at the difference in size between this peak and the EPA peak. And you can see in this sample, the difference in size is about 5. So the ratio in this case is 5:1. It's really simple. And it's called a relative analysis. Like the arachidonic acid is 500% compared to this one, relative. And the fact that the test is or the service is a relative analysis becomes pretty evident when you see how the samples in real life look like, because samples can look like A and B with a lot of sample, a lot of blood, and like E and F here with very little blood. So if you use sample A and B with a lot of blood, you will have high peaks. If you use E and F with very little blood, you will have small peaks. But look at the ratio. It's always the same. So it doesn't really matter how much blood there is on the card. The results will be the same anyway. Of course, given the fact that the samples incoming look like this, look at this card, massive amounts of blood. And we have some samples with almost no blood. So this is the backside of the card, because when you sample, you should always take a look at the backside as well, because the size of the circle of blood should be the same on the backside as the front side. If you have this similarity, you have saturated the paper and you will be able to collect perfect samples like these ones. But for the fatty acid test, we are okay with this kind of sample quality. But for the vitamin D and gut test, we need this type of quality. So make sure to have proper quality on the samples you send us. Then dealing with the question that we receive a lot, is the Encino omega-3 index the same as the Harris omega-3 index? Well, the simple answer is no. So recently there has been some changes on the Encino websites. I don't know if you have noticed. It now says WB after omega-3. So this is whole blood. So this is because we use whole blood, right? And the omega-3 index is the sum of EPA and DHA in whole blood. But I think this is a nice change and distinguishes the Encino index from the Harris index. So the Harris index is actually defined as the sum of EPA and DHA in red blood cells, so purified red cells. You wash them 3 times from the blood, so it's free of plasma. But this is a lab procedure that is not possible to do in a high volume home collection setting. So because of this, Harris and others actually is using DBS, and they do a mathematical kind of pseudo back calculation from whole blood to red blood cells using something we call a regression equation. So this is performed by taking, for instance, 100 samples from 100 people. You analyze the whole blood. This is on the x-axis here. Maybe you get the value of 6. And then you measure the isolated and washed erythrocytes, red blood cells from the same 100 people. And the numbers are then plotted on the y-axis. And then you have this regression, this correlation between these two data sets. And this tool can then be used to recalculate from whole blood values to RBC values. But this is kind of cheating, because you don't actually remove the plasma. It's only a mathematical simplification and recalculation. But as every mathematical calculation, there are uncertainty involved. And when you use this test to check the difference between two tests, like test one, test two, or two groups, or you want to follow the intervention when you take supplements like omega-3, it's much better to just stay in whole blood and not do the calculation, because the data will be more precise and more accurate. So how do the assays perform? Well, to check this and to monitor this, we use something called quality control samples. So these are dry blood spots prepared from blood bought at the hospital, maybe 20 liters. We mix it together. We make tens of thousands of dry blood spots. We dry them, we put them in the freezer. And every time we do the analysis, we put some of this in front and behind the Cincino samples. And since these are almost identical, we expect them to give almost the same result. And each of these dots are the result from the analysis of one quality control sample. And you can see they are not perfectly identical, but they are spreading with the coefficient of variation around the middle value, which is the green line here, 100 nominal value. So what we are looking for are trends going up, going down, or like extremes like this one. So if you find something like this, we need to check the calculation, see if we did something wrong. If you find it, we can correct it and upload the results. If you don't find anything, we need to reanalyze the whole batch, being 150 samples. So this is why we need the second ring, the B sample, to do this reanalysis. But you can see it's really rare, right? It's one out of very many. Yeah? Okay. So using this quality control plot, we can calculate or estimate the precision, the relative standard deviation, or the analytical coefficient of variation, CVA percentage. So since we have 11 fatty acids, we have 11 of these plots. So this is the plot for EPA, since this is the most important, I would say, fatty acid. And you can see it's going up and down around the average of 100. And this is a very tough test because it includes 1 year of analysis, different instruments, different people, different temperature conditions, exchange of parts that break down, and so on. So it's a very wide test of the worst case peak-to-peak variation in the analysis. But we can calculate back the real CVA from this, and you can see that it's 4.35%. So this table then lists the CVAs, the precision for all 11 fatty acids, and you can see it spans from 1.5 to 11 for one of the fatty acids, but on average, it's about 4%. Then I would like to show you what we really report. There is no text, no advices, no pictures, not anything. So this is a flat file, very simple. We have the ID up here for the person, and then we have different codes for the different fatty acids and the result. 1 person, 2 person, 3 person, and so on. A very large file with thousands of results at a time. Sometimes when there is not enough blood, we have other codes. So the code for not enough blood, for instance, is C. So then we replace the number with a letter like C. Moving on to HbA1c, you can see that this is the control plot. It's very narrow. And out of 800 samples, you can see that the overall CV during a year is 3.8%. And then if you recalculate the CVA percentage, it's 2.7% overall for a year, which is really low. And the reason for this is that this test can be used for diagnosis, and then the criteria are very, very strict. Um, and these are the data from the initial validation of this assay. And you can see that the overall CV of 2.7% matches pretty well with the CV that we found at that time for the between run variation. The precision, repeated measurement the same day, is very, very low, 0.5% to a few percentage. And looking at the accuracy, you can see this. This is how true is the value, how close is the measured value to the true value, the nominal value. And you can see at 3 different levels, low, medium, and high, we have very close to 100% accuracy for all samples. We also participate in something called external quality assurance programs. This is arranged by a hospital or an academic institution somewhere in the world. This one is Swedish, from the Sahlgrenska University outside Gothenburg, called Equalis for HbA1c. What they do is they, like 10 to 12 times per year, they send out a sample to all the labs that participate in the program. It could be 10 labs, 100 labs, 1,000 labs, depending on the biomarker. This is a very popular biomarker, so it's a lot of labs participating. And this sample has a nominal value, a true value. We don't know the value, of course, when you get the sample. We analyze it, we report our result, and then after this, we get a report from the organizer showing that how close we are to the true value. And you can see in this case, it's 41, and we measure 41 and 42, which is high accuracy, aligning with the accuracy that we found in the validation. Vitamin D. So the 2 previous tests, HbA1c and the balance test, are relative tests. They are both reported as percentage-ish numbers. But for the gut test and the vitamin D test, there are absolute numbers reported, like nanograms per milliliter or nanomoles per liter. And then we have more strict requirements for the sample quality. So this would be a sample with low quality. And you can see we can only have 2 punches from this sample, 1 from each, then leaving no backup sample for reanalysis if it's necessary. For the other sample, which is a perfect sample, filling each ring with 1 big drop, you can see that we can have 4 punches from 1 circle, leaving a full circle for backup analysis if necessary. And this is important, because look at this slide. You can see this is the data for 4 punches, 3 punches, and 2 punches. 2 different samples with different concentrations. And you can see that we have 4 punches, meaning we have like double amount of blood compared to 2 punches. The CV is less than 6%, which is really good. And then moving to 3, we still have 6%, but when we have only 2 punches, half the amount of blood, the CV, the precision get much worse. And the reason for this is that when we have less blood, we have a lower signal, fewer molecules, and then the signal to noise gets worse, and this leads to less accurate result. So this is why some of the tests on gut and vitamin D is not accepted, and you will have an error code instead of a result in the report. So this is the QC plot for vitamin D. You see, we have a few more extremes here that we need to check than we had on the balance test. This is natural when it's absolute test. Calculating the CVA from this QC plot, we have a CVA of 9.1%, which is very good, I would say, for this type of analysis performed by LC-MS on a very low concentration. Then I would like to mention that although the CV is low, 9%, the absolute variation in results will differ depending on the concentration. So 9% around a value of 75 will give values spanning from 62 to I think it's 88 here. But when you look at a higher concentration, like 300 and 400, you can see that at 400, the possible kind of natural inherent variation is from 329 to 471, although the true value is 400. And I think it's nice to know this, because you can expect pretty large differences from a sample with high concentration delivered 2 times to the same lab. But it doesn't really matter, because the important stuff is down here around 100 or even around 50 if you're deficient or not. Up here, you're high, very high, or very, very high. It doesn't really make a difference. And so sometimes we get mails from people that have sent a sample or gone to the doctor and measured their vitamin D, and then they compare this with the results from Vitas. And on this slide, I have simulated kind of comparing results from 2 different labs. Lab 1, maybe Vitas, found a value of 75 on average, but it can span between 62 and 88 based on the 9.1% CV. While the other lab might have a slightly different accuracy and the same CV, and then you can see the possible value between these 2 labs are from 62 to 97, kind of almost double-ish. And this is for 75. And moving to 400, you can see that the possible value is 518 to 329. It's a really big difference. And this is also reflected in the criteria in this external quality assurance program from DECAS, the world's largest quality assurance program on vitamin D. More than 1,200 labs are participating in this program. And you can see the criteria is less than 25% difference. So the take-home message for you is not to send your sample to different labs. Use the same lab to compare before and after taking vitamin D, the balanced oil, or other kind of intervention to kind of change your balance or change your concentration of a certain biomarker. Then a few slides on the gut test. This is relatively new. It's fully validated test. It's performed by LC liquid chromatography using UV and fluorescence detection. The instrumentation looks like this. We currently have 6 of these for this analysis now. And the performance of this assay is very good. The accuracy is close to 100%, and the RSD is less than 5%. Then I would like to remind you what the responsibility of Vitas is. The responsibility of Vitas is to receive the samples, perform the analysis, and secure that there is high quality on the results that we deliver. We never receive any names, sex, address, emails, body weight, anything, ethnicity, something like this. Never, never. So we cannot answer this, and we don't want mail where people say, "Hi, my name is this is my ID, can you check the result?" So this is GDPR breach, and all this kind of questions should be directed to Cisino and Cisino only. Then for the last section, some thoughts about how we can stay ahead of the competition. As I see it, what makes this collaboration or this service different is, of course, many things, but one of them that I think is quite important is the collaboration between science and a commercial force like Cincino. Having a global presence with thousands of people out there every day with a message. And of course, the testing, being able to test effects of products, to follow changes, to have like a personal nutrition approach, because We are all different and we need different doses to reach the optimal concentrations of these building blocks in our blood. So I think the combination of the science and the commerce, the test, and the fact that Cisino has products that are able to modify the test results, bringing them into balance. This is an important part of the success and maybe the magic of this service. So what I think we need to do to stay ahead is to innovate every day. We need to innovate, lean forward, never rest, innovate, innovate, innovate. New biomarkers, new tests, and new concepts. I mean, we need to make sure that we keep the scientific credibility. Um, and of course, as numbers are increasing, keep the speed up, scale, have some resources left for peaks that will arrive maybe this autumn. We need to make sure that the customer sees a value, which is hopefully unique for this service, not delivered by others. And we need to protect the know-how and the IP that we generate as we do this innovation. For the capacity, I think we are well prepared. We have these robotic systems, and the current capacity is 90,000 samples per month, and it can easily be increased. We have this copy-paste process now where we can lean on 15 years of innovation, and we can just copy-paste what we already have. Doesn't mean that we rest. We also innovate every day. And I would like to show you this picture. The first time I showed this was in the previous session today. So this is an example of our most recent automation. On the left, in the blue, you can see a blue and gray robotic. It's a cobot, collaborative robot. It's a kind of a mini robot, similar to ones used in the car production by Tesla, for instance. And we are now teaching this cobot to do lab work. And actually, it will collaborate with another machine, the ones with the red cover here. This is a capping machine that we use to cap the vials, 1 million caps per year. And this job was previously done by humans. Now it's fully automated, two robotic systems collaborating. And the human is now kind of only washing the cabinet to assist the robotic system. So my vision for the future is that we will have many of this. Probably we will have three more of these robots this year already, before end of year 2026. And that they will collaborate with all other machines we have in the lab and close the gap between the automation we already have. And as you can see, there are no humans on this picture. Doesn't mean that we don't want to have humans. The thing is that the ratio between robotics and humans will change. Currently, it's 3 to 1. And I think in the years to come, it will increase to 4, 5, and 6 to 1. So this is what I think is important to do to stay ahead of the competition. Thank you.